Yeah, hey, thanks for the introduction. Hey, everyone.
Don't forget to start.
It started. Recording has started, Andre, yes. So today we'll be talking about mostly web components and preferably with Skate.js. Little about me. Hello, Timisoara. My name is Martin Hochel. I work as software engineer in Prague, Czech Republic, for a company called Embed IT. You can follow me on Twitter. I don't tweet about cats. I tweet about serious stuff, so feel free to follow me. Beside that, I'm running the biggest JavaScript meetup in Czech Republic, and mainly in Prague. It's called NG Party. NG not for Angular, it's next generation, okay? You see what I did there? I'm also author of NG Metadata, the best Angular one. Maybe you heard that. I'm also member of core team, Skate.js core team. And as you can see at the slide, maybe not, I try to do open source a lot. And like, I have also normal life. So when I'm not coding, you can see me on my surf or snowboarding, skateboarding, you name it, all the boards. So today's talk will be just about skateboarding, okay? So let's learn the fundamentals. So this is how you hold it. You just pop the tail, okay. Just kidding, maybe next time or after the talk we can learn some tricks. All right, we are all software engineers. We like to solve problems, right? So let's set a problem. How would you create a reusable widget? Which one of you will be using like vanilla JavaScript? Shout JavaScript. Anyone? Really?
JavaScript.
One, perfect. Who will pick jQuery? Shout jQuery. Come on. jQuery, okay. React? Shout React.
Yeah.
One more time. Who will choose React? All right. Vue?
You.
Too few views. Angular?
Angular.
Hey, Angular. Cool. Nice. All right. So let's say this is like the implementation size of the widget, okay? This is just contrived size, but let's say, like for the comparison, obviously the biggest size will be vanilla JavaScript, right? Because you don't have these all abstractions. So, okay-ish, but let's say a more important size, important thing, it's the library size, okay? So obviously, if you would pick vanilla JavaScript, 0 kilobytes, because you are using the platform. Sounds good. If you pick jQuery, your users have to download 30 kilobytes of some library just for one widget, which is like, I don't know. All right, React, 2 plus 30, 35, let's say. This is the fiber. It's 6 kilobytes smaller than the previous version, but still like 30 kilobytes just for one widget. I don't know. Vue, wow, 20Ks. We have a winner here. Maybe, maybe not. And for those of you who will pick Angular, 75K, like just for one date picker. I mean, I don't know. Anyway, let's say you pick one of those. What would you do? You will start implementing those CSS frameworks to your specific library, right? So material design in React, Vue, in Angular, Bootstrap, whatever. And I have good news for you. Next year, there will be no new framework called Future.js. And what will you do? You will rewrite everything. Well, but that's totally doable. Why not? All right. That was problem one. We solved it, let's say. Let's introduce a new problem. How would you create an interoperable widget? What I mean by interoperable, let's say this is just a black box and it will work with any existing framework technology. How would you do that? Maybe he knows. Actually, you cannot do that. It's just not possible with frameworks as we know them today. So, web components, anyone? All right, so today we will learn what web components are, okay? why, what there are, and how to use them. 3 fundamental things, okay? So let's start with why. I introduced 2 problems, and if you're using web components, both are solved, done. Why and how, I will show you later. But keep in mind, web components enable you to create reusable, interoperable widgets. So now maybe you're asking, okay, Martin, so you are telling us that we can write whole apps with web components? You can, but it will hurt, as we will see later on. But you can, definitely you can. All right, what is a web component? Web component is a new platform primitive for creating reusable, interoperable widgets. So it's no framework, it's just there in the browser. Like JavaScript, there is web components and the DOM API. So basically zero kilobytes for your users, which is awesome. So this is how you write web component. Okay, this is some new HTML tag, skuser, and browser renders something like this. And how is this even possible? Because it's magic. Obviously, it's not a magic. We are software engineers. We don't believe in magic. All right. So web components is a part of 4 specifications in the browser. They consist from custom elements, templates, shadow DOM, and JavaScript modules. Let's take a deeper look at custom elements. So those custom elements are the new tags. Basically, you are teaching the browser to do new tricks. And how can you do that? You have to create the custom element. It's just a class which extends the basic HTML element. So no rocket science. You're just using the existing platform and DOM. And you have to register it within a global registry of the browser with very specific constraint. It has to have unique name and needs to use hyphen as a prefix because we don't want to create conflicts in the browser. So eventually, in the future, if we will have some new native tags, we won't get into conflict of the names. So you do just class, register, and you can use it within your HTML, and it will just work. So simple as that. Custom elements also introduce APIs, which again we need, right? Because we want to somehow configure the elements and interact with them. So for these particular reasons, custom elements provide us with attributes and properties for passing data from parents to the children. Then we have events from children to parent communication and lifecycle hooks. Let's talk about attributes and properties in the terms of primitive data. What I mean by primitive data, I mean JavaScript primitives, right? Strings, numbers, Boolean, you name it. So you can set attribute or property via this imperative API, which is just DOM, right? That the $0 is a reference to the element, just to make things clear. So you can do it like this, and declaratively, just like this. And just a note, if you write HTML like that one on the screen, basically under the hood, the browser is calling this set attribute with the value. And very important thing is you can set only strings, all right? Every time set attribute is called, the value will be string. So you have to cast to specific type, which is not very convenient, but it works. All right, so how do you implement this API? So this is like the implementation, and let's go step by step. So first off, you need to create some private properties. In our case, is the age, and then for reactivity, getters and setters. And again, this is just JavaScript. It's not artificial abstraction, okay? So if you want to set the property via this $setAge here, again, we have the internal property and the setter and the getter. And if we set the value, the setter will be invoked. And within the setter, we are updating the internal property, and we are calling some render. Render is not a part of the specification. That's just our custom implementation to trigger re-renders. So like that, right? Not pretty fancy, but it works. And if you want to support attributes, there is another API. So let's say you want to set attribute via this set attribute. You need to define explicitly a getter of attributes that you want to create mutation observers, right? Because otherwise, the element would need to listen to every attribute, which is like performance nightmare. So you have to explicitly name the attributes that you want to watch. And if that changes, this attribute change callback lifecycle hook is triggered, where you update your internal stuff, the property, and eventually this will call the setter, and setter will render. So we have reactivity by default. Not pretty nice API, but it works. What about rich data? What I mean by rich data, objects in JavaScript, right? JavaScript, everything is basically object, array is object, object is object, promise is function, which is an object, so just objects. Again, imperatively, you can set it like this. You're just setting to the property the array of objects, and declaratively, you can stringify. Don't ever do this. Why? Well, because every time you do this, it needs to be parsed, and that could cost a lot of computing power. And even worse, if you are using some framework, you will immediately lose the data binding references, because, as I said, every time new reference will be created, and you will be lost, and your data binding won't be working. So unfortunately, we cannot use rich data declaratively in HTML. That's also one of the few reasons why we have thousands of frameworks. All right, let's implement the tricks property. Again, the same song. You need to create internal property, setters, getters, and when we set the property, this setter will be invoked, which again will trigger render, and we will see the updated content. Not so bad, but I don't know. We can do definitely better. All right, what about events? Like, events are very important because those provide an API for an element to notify outside world that, hey, something changed within, or there was some reactions of the user happening inside, and hey, parent invokes a logic and propagate the new data. So we are in need of events, eventing system. So again, you can listen to those custom events imperatively via added event listener. And there is unfortunately no way how you can create listeners declaratively in HTML, which is sad. And how you implement this eventing system? You just create some object. You can also send some data via this special detail property. Then you just create an instance of event with your particular unique name of the event, and you just dispatch. Simple as that. All right, what about lifecycle hooks? So we have a few lifecycle hooks in custom elements. First off, constructor. This is not really a lifecycle hook, it's just JavaScript. Attribute change callback, we already covered that. You need that if you wanna support reacting on attribute change. Then we have connected callback. This is called when you mount physically the element to the DOM, and the counterpart, disconnected callback, which is called when you remove the element. Okay, so we know what are custom elements. What about template? So template is a new tag within the browser. It looks like this. Obviously, you need to use the template tag with some specific identifier, and what is really important is that this template is not parsed. It's just inner element within your browser. It's parsed in a runtime when you instantiate. Okay, so there is like no performance bottleneck for your template parsing. And you can create inside the styles and some markup. And again, because it's just DOM, you don't have some constraints like you have with virtual DOM, that there has to be an explicitly root element. You just create a markup as you please. And then how you use this template within custom element. You just query for the template. You can also create it imperatively within the constructor. It's really up to you. And then you are cloning the new instance, which is a huge performance win, because maybe you are thinking that every time you will use this element within your DOM, that every time it will be parsed, the whole template. That's not true. There's the specific feature of the template tag that it's parsed and instantiated just once. So you are not getting in the performance overhead of parsing those HTML templates, which is pretty awesome. And last but not least, you append the template to your element. Shadow DOM. Shadow DOM is the most important feature of the whole specification, in my opinion. Let's take a look. So again, this is our SK user. It renders this. Ooh, so how is that possible? Okay. So what browser renders is this output. So again, we have SK user element, and it renders some shadow DOM within this shadow root. So, okay, that's understandable, right? But what about this image? This markup is actually called light DOM, not DOM, okay? And okay, Martin, thanks for explanation, but still, like the light DOM is rendered not at the same spot that it was defined. How is that impossible? That's possible because the slot projection API provided by Shadow DOM, by which we are telling the element, like, hey, this content will be rendered inside our private template at this particular position, and we are not mutating the DOM. It's just using like pointers to the existing DOM nodes. So like there is no performance overhead of this parsing, which is pretty cool, and it allows you to create really composable elements via this projection. And maybe you notice this style tag within the shadow root. Okay, let's say you define some styles for div inside the shadow root, and some other guy will also define some styles in outside of the component. So maybe you're thinking, all right, there will be a clash because we have Cascade and like CSS is global, etc. That's not the case. Like you cannot pierce Shadow DOM. Everything that you define inside is private, and you cannot override it. Actually, you can with CSS variables, but those are only feasible for some theming, right? So you cannot redefine the whole selector and CSS style for some div element. So this is, again, pretty powerful. And last but not least, how you create Shadow DOM via this imperative API. Yes, imperative it is. And it is. And last but not least, you just append the shadow. You append your template to the shadow. So as a recap, Shadow DOM isolated sandbox. We have projection API and a really native scope CSS without any framework hacks. Last of the part is JS modules, which is not really a true part of custom elements, but it's there, and you define it like with this. You have to tell the script tag it will be a module with this type, and then you can just use ECMAScript modules for loading your widgets, and when it loads, the browser will register the element and render your markup as needed. Okay, so now you know what is a web component. Hey Martin, what about browser support? Glad you asked. Let's see at the table. We love tables, right? So as you can see, Chrome, Opera, and Safari have 100% coverage of web components. So you can start using them right now and ship to billions of users without any third-party dependencies. All right, what about IE or Edge? Good news, it's on their to-do list. So soon enough, a major of the browsers will implement this specification. Firefox, I don't know, but you can open 1,000 tabs in Firefox, but they don't implement web components yet. But still you can use polyfills, so looks good to me. All right, we know what. Let's see how to build a web component in a reactive and type-safe way. So, what are we gonna build? This is some app that I built. It's just a karate application where you can learn new skateboarding tricks. Okay, I can learn some shove it. I can set the difficulty. And I will learn it, and it will walk the event and add it to the list. And also I can remove the tricks. No rocket science. What is the architecture of this app? Again, we are using component module provided by WebComponents. So we will create a component tree. In our case, there will be just two components, the root, SKApp, and SKUser. And we want to implement reactive data flow. So basically, SKUser will be stateless component, which will have some properties, name, age, tricks, and it will emit custom events when something changes. So the app will be responsible for any logic, and it will propagate the new data and will render in one-way reactive data flow. So let's start implementing. Because we are using TypeScript, we will define model for a trick. Then we can define like the props of our component, and then we will write the template. Like, there is a lot of stuff. Like, you don't have to read it all, just for imagination. Then we need to define properties of that element, right? So setters, getters, all the way. And this is something new. Of course it's new, because it's not the part of the platform. Basically, you are responsible. How are you gonna run the mutations and changes with your template? So in this case, I have created some view property which will imperatively query the template and reflect those changes. Not pretty convenient, but this is what you need to do if you want to use native web components. And last but not least, you need to define that element to the browser. Okay, so that's one thing. The second thing is, again, construction. So you need to create shadow root, append that shadow root to your element. Here I'm querying explicitly for those elements within the shadow root. And there is a form, so I have to create, again, imperatively listener for submission. This is getting messy. All right, whatever. Next thing, we need to leverage the lifecycle hooks for reactions. So we have attribute change callback. If attributes changes, we need to trigger render. When we mount the component, we will not trigger render because we want to immediately propagate the values to the view. So there we go. And I don't want to continue. Like, this is the whole implementation of just the one component. It's kind of a lot of code, right? But yeah, it works. I don't know. So we know why, what, and how to implement the components. And at the beginning, we had the problem which I was telling you it's solved by web components, and let's see how, right? How frameworks libraries can interop with the web components. So if you're using standard HTML, that's nothing new. You just define your custom element with. Just take note, you cannot set again declaratively those rich data because the reasons that I mentioned before. Let's say you are using React. So this is just JS6, but take a look at the tricks. Actually, this won't work in React because React really doesn't like web components and the platform overall. So what React will do, it will just stringify the value. So what you will end up is the tricks will be object-object, which is not what you want. But fortunately, there are much nicer alternatives like Preact, and Preact loves the platform, and this will work as intended with Preact. Angular has first-class support for web components, so you just use traditional data binding of Angular. And Vue is also awesome and really loves web components. There is just one trick. You need to explicitly state that .prop if you want to set rich data. Because by default, what Vue is doing, if Vue encounters a not Vue component, it will set the properties to attributes. So that's why you have to be explicit to tell Vue, hey dude, this is a property. Vue with it. And if you want to know more, there is this awesome website created by Rob Dobson for Google, custom elements everywhere, and there are like unit test coverage, which frameworks have what support of interop. As you can see, Angular and Vue have full support. React is pretty decent, and React is like 16. Come on. All right. Let's keep it real, okay? So, what's the real problem with web components? So maybe you noticed I used word imperative, a lot of stuff, right, during the explanation, and really the developer experience is quite painful. But you are all smart developers, and eventually, when you will start using web components, you start building some abstractions, some functions to be reusable, to have better developer experience. And I have good news for you. You don't have to do that introducing Skate.js. So let's skate. What is Skate.js? Skate.js is reactive, pluggable web components microlibrary. Currently, stable version is 4. We are working hard on 5, and we have some stars on GitHub. You can give us a star if you want. Reactive. What do I mean by that? All right. Let's say we have some logic, we have some view, that's our component, and we have these props. Skate has only single source of truth, like React, and those are props. So if some logic is executed and the component gets new props, we trigger a synchronous re-render, which is performant like Fiber does. So everything is async and batched, so you get top-notch performance. And again, if something changes, you notify from the view via some user action, in our case, custom event. And again, the logic has to process it and start the cycle again and again. So we have reactive one-way data flow with Skate and web components. Pluggable, what do I mean by that? Well, the whole library is a set of mixins. Do you know what are mixins in JavaScript? Anyone? Okay, so mixins are just functions which return some extension of something. What I mean by that, like those mixins are just functions that allows us to do like multiple inheritance in JavaScript, because web components uses classes, so we have no other option to go functional, but those mixins are just functions that you can compose together and create some abstractions and wrappers. Next thing, very important thing with Skate, we have custom renderers. So we don't care what you want to use for rendering. I will show that later on. And last but not least, Skate comes with fine-grained lifecycle hooks. So we have some alternatives like you have with React, should component update. Something similar is built within Skate to provide you the best developer experience, so writing web components. I mentioned micro library, right? It's really micro. It's not even 3 kilobytes, so pretty nice. All right, let's build something with Skate, shall we? Some ollie tricks or kickflips, maybe. All right, so let's learn some code tricks, shall we? That's not me. Cool, so Skate is like core Skate doesn't have any default renderer, so you have to choose one. But we provide some default ones. We provide renderer with Preact or with React, with HTML, a renderer for Vue, it's in progress, or you can build your own custom renderer. It's really up to you. With Angular, if you want, 75 kilo. So in my example, I like React. I like React as well, but obviously I have to use React because it loves the platform. So I will choose React as a renderer. So this is how it looks like. I just import with component mixin from skate and with React mixin from React renderer. And I will build my base component class just by composition of those functions. So that's step number one. And then I have to implement this component, okay? So this is the whole implementation, like pretty straightforward. Again, I have to import stuff from React, from skate, from my base, that's the base component. I will define some props because I'm using TypeScript. And then I'm creating a new class that is not extending HTML element, but this component, which comes from skate. And there are some strange things, those brackets, those are generics, because we are in type land, so don't be afraid. It's props, class, and you have to just define the element like we used with vanilla. So nothing new.
Excuse me, what is base? Or you're taking that?
Base?
Yeah.
Base is this base class, which we create from composition of those mixins. So we have been here. Right. Then we need to define API. For sure, you remember how it was done with vanilla web components. These getters, setters, renders everywhere, just a mess. With skate, you have just this straightforward API via static props. Again, it's immutable because we are using typing system. We are explicitly telling it, hey, dude, this is really immutable, so no one can change this. And we provide some default prop casting functions, in this case string, so it will cast the values always to the string. And last but not least, you have to render stuff, right? In our case, it's called render callback, and you just return your virtual DOM rendered by Preact, because we are using Preact for the hypertext function. So nothing new if you are familiar with React. And last but not least, because TypeScript is a really pluggable system, we are telling the JSX definitions that, hey, this new tag has these props, all right? And by this, we are enabling the strict and explicit type checking of our component by any consumer. So this is like a demo. I'm writing an app with Preact. Okay, this is my app, and I'm using this XLO custom element. And TypeScript is yelling at me that there is a missing name property because I defined it. And I see the IntelliSense, it should be a string. So I will use string, everything is fine. And if I will provide wrong data type, like number, the compiler will yell at me that, hey, this is not a number. So I don't need to go to the browser. I got immediate feedback thanks to the type checker, which is pretty awesome from the developer experience. So that's Skate in the nutshell. We are not going to re-implement the whole app with Skate. I have provided all examples under this repo. It's on my GitHub profile. I will share the slides with you so you don't have to take pictures or whatever. And there are like comparisons of all implementations of the same app in vanilla web components and with Skate, just that you can compare side by side. And from the visual perspective, like this is the code needed for the SK user with vanilla, and this is with Skate. It's not that much difference, but the biggest difference is with Skate, your view is powered by data, okay? If you are creating with vanilla, most of the time you have to really interact with DOM and do some dirty hacks, but with Skate, the source of truth is your data, which is what we all know from these shiny frameworks. And now let's learn some advanced tricks with Skate, or maybe not. I mean, Skate.js is just library, but we have kind of huge ecosystem. With Skate, we provide those three libraries. SSR enables you to server-side web components with Shadow DOM, which is really a deal breaker for let's say if you are e-commerce, you need server-side, right? Doable with web components. We have this val library, which will monkey patch any virtual DOM abstraction. So what I mean by that is, as I mentioned when I showcased the React, right? The React uses stringify to unknown tags, but with val, you can monkey patch the create element, and you can use those property bindings, and it will just work. So you don't have to provide any other hacks. And bore is just a unit testing utility for web components. Okay, what is the skate roadmap? So version 5 stable will be coming out pretty soon. We have no default render in core. We have mixins for everything. We have APIs for turning off Shadow DOM, because sometimes you don't want to use Shadow DOM. You can do that with skate as well. We provide server-side rendering, and this is a deal breaker for me. I really love testing, and I was really annoyed all the time to set up Karma and run all those browsers. And with Skate, you can run unit tests for web components within Jest environment. It's pretty amazing. If you want to support us, we are at Open Collective. It will be great. Keep in touch. This is the Skate repo. Skate is on Twitter. You can follow Trey Shugart, which is the main author of Skate, who started all of this. Obviously, you need to follow me. And let's recap, like what we learned today. So hopefully now you know why, what, and how to use web components. Now you know that's only way how to interop with all existing frameworks nowadays. And even better, you know that Skate.js exists and what benefits it provides to you as the author of web components. As for the closing, like, do you think that web components are future of the web? I don't think they're future, because the future is right now, all right? Angular has already a pull request for providing web components. Even Dan Abramov tweeted that React has now custom renderers, so you can render web components from React. Even you, the author of Vue.js, tweeted this, that he will try to do soon a renderer from Vue to web components. This Svelte framework is doing it already, and there is the new thing called Stencil.js, which is a compiler to web components. So if you like abstractions, Stencil is a way to go, because it's really, really nice. So everyone, in the end, will support web components. So yeah. Last thing, please submit the feedback, because the feedback is your payment to the speakers and the organizers. So provide some feedback, please. And keep calm and use web components. And thank you very much.